The East Pagoda of Yakushiji Temple, Nara Prefecture. The Suyen, or finial of the pagoda, features the image of Hiten, a celestial maiden flying high in the heavens, playing music and dancing, her veil a-swirl. The Muses A is the 13th scientific satellite launched by the Institute of Space and Astronautical Science, or ISAS, under the aegis of the Ministry of Education, Science and Culture. Named Hiten after this heavenly maiden, the satellite soaring through space of the Earth-Moon system, conducting its experiments. MUSES is the acronym for the Mu rocket-based space engineering satellite. The MUSES A is the first satellite of this series, one designed to establish the space technology required for future lunar and planetary missions. The MUSES A primary objective is to acquire and verify an orbital control technique called swing-by. Swing-by alters the velocity of a spacecraft by utilizing the gravity of a celestial body to let the spacecraft move as if it is being swung around that body. The MUSES A acquires this orbit control by executing a double lunar swing-by, a technique that increases the speed of the spacecraft while it is passing behind the moon and decreases it while it is passing in front. August 1989. All components and equipment of the spacecraft are delivered to ISAS, Sagamihara, Kanagawa Prefecture, and assembly of the satellite is started. First on the list is the assembly of the reaction control system designed to perform complicated attitude and orbital control operations. The reaction control system consists of 2 tank modules containing the hydrazine fuel, 4 engine modules, and 6 valve modules. After assembly of the reaction control system, various instruments for engineering experiments are mounted on the craft. The X-band downlink communication system has been adopted on the MUSES A for the first time on a Japanese satellite. Orbit determination experiments are conducted using an optical navigation system which has proven very effective for improving interplanetary navigation precision. This is the world's first experiment carried out with a system mounted on a spin-stabilized type of spacecraft. A fault-tolerant computer is mounted on the MUSES A. This computer can continue processing even after partial errors or malfunctions, minimizing adverse effects caused by such faults. The dust counter developed by the Technical University of Munich in West Germany. Using this counter, various cosmic dusts in space are detected, allowing their masses and velocities to be analyzed jointly by German and Japanese researchers. An experiment to insert an orbiter into orbit around a celestial body is another major objective of the MUSES A's missions. This miniaturized satellite mounted on top of the main body of the spacecraft will be released from the spacecraft on its first approach to the moon. A small, solid fuel rocket installed in the orbiter is then ignited, sending it into lunar orbit. Highly efficient indium phosphorus solar cells are used as the power source for this lunar orbiter, replacing the more conventional silicon cells. These experiments are important steps toward forming the basis of an increasingly sophisticated future space technology. The MUSES A satellite itself is composed of the cylindrical main body, 140 centimeters in diameter and 79 centimeters in height, plus a 26 hedral-shaped lunar orbiter, 40 centimeters in distance between opposite faces and 36.5 centimeters high. Its total weight is about 197 kilograms. In preparation for the launch scheduled for January 1990, various tests, including vibration and shock tests, a dynamic balance test, and a thermal vacuum test, are conducted to confirm the satellite's performance during the launch and its one-year mission life in space. The satellite and its launch vehicle are mated to check their mechanical fitness. A Mu-3S2 rocket is used for the launch of the satellite. The Muses A spacecraft is to be launched into an orbit approaching the Moon, and the Mu-3S2 rocket has successfully proven its capabilities for this purpose, not only in past launches of the Halley's Comet Explorers, the Sakigake and the Suisei, Japan's first spacecraft into interplanetary space, but in those of the Ginga and Akebono satellites as well. Two upper stage rocket motors, Kick Motor M and Kick Motor L, have been newly developed for use on the Mu-3S2-5 rocket. Manufacture of the Kick Motor M is underway. This rocket has the feature of being encased by a carbon fiber reinforced plastic chamber. The Kick Motor M, mounted on top of the third stage rocket, is intended to put the satellite into its lunar swing-by orbit. On May 20th, 1989, a ground-firing test was conducted at the Noshiro Testing Center in Akita Prefecture. The test results were perfect and confirmed the capability of the rocket. The newly developed Kick Motor L plays the very critical role of inserting the orbiter into lunar orbit after its separation from the Muses A mother craft. November 28, 1988, the Kick Motor L was also subjected to a ground firing test and its performance confirmed. In line with the development of the Kick motors, the interstage sections for the upper stages were also newly developed and tested. October 1989. Assembly of the Mu-3S2-5 rocket is started at the Kagoshima Space Center, Kagoshima Prefecture. Assembly of the first stage rocket motor. The Mu-3S2 is an all-solid fuel launch vehicle with an overall length of 27.5 meters and a total weight of 61.3 tons. This launch vehicle is equipped with several kinds of control systems to control its attitude in flight. A secondary injection thrust vector control system is used during the first stage firing. Assembly of the strap-on boosters. A movable nozzle is used for each of the strap-on boosters. At the tip of each tail fin, a small, solid fuel rocket motor is mounted to control the roll motions of the vehicle. The second stage is mated with the first stage. The attitude of the vehicle during second stage firing is also controlled with a secondary injection TVC system and a hydrazine-fueled side jet. The third stage is oriented in the direction of the desired injection angle and then spin stabilized by the second stage rocket's side jet system before separation. Uchi no Ura on New Year's Day, 1990. January 2nd, the Muses A spacecraft arrives at the Kagoshima Space Center. The satellite has been through its final checkout before being mated with the launch vehicle. Covered by a nose fairing, the upper stages are mounted on the second stage. January 24th, 1990, Launch Day. The launcher begins turning toward the launch point. The launcher is set at a launch elevation of 73 degrees with an azimuth of 93 degrees. In the blockhouse, the final countdown is in progress.
0.
Liftoff at 20:46 hours, January 24th, 1990, Japan Standard Time. This is an image taken with the rocket-mounted camera. Separation of the strap-on boosters. The second stage rocket ignites. The firing and flight of each stage proceed normally. Thrust vector control of the first and second stage rockets, as well as attitude control prior to the ignition of the third stage, progress smoothly. The third stage is ignited normally, 281 seconds after liftoff at an altitude of 219 kilometers. 373 seconds after liftoff, the kick motor M is ignited. It's firing normal. The 13th scientific satellite Muses A is inserted into an elliptical orbit with an apogee of about 290,000 kilometers. Now successfully launched into its planned orbit, it uses A is named Hiten, and given the international designation number 1990 007A. At the Kagoshima Space Center, the first telemetry signals from Hiten in orbit are received at 3:01 a.m. January 25th. In Uchinoura, satellite communications are conducted using a new 20-meter dish antenna, while the spacecraft is relatively close to the Earth. From this point, orbit determination and control are carried out. After circling the Earth 5 times, the satellite makes its first encounter with the Moon. After launch, satellite tracking operations are transferred from the Kagoshima Space Center's 20-meter antenna to the 64-meter dish antenna of the Usuda Deep Space Center, Nagano Prefecture. Using the 64-meter antenna for communications, the lunar orbiter is released from the mother spacecraft Hiten, which initiates repeated swing-by operations. Satellite mission control is conducted by the Sagamihara Spacecraft Operations Center in Aisas. This center executes telemetry data acquisition and operations, including attitude and orbit determination and their precise control. This picture shows the state of the spacecraft passing the perigee just before its first encounter with the Moon, a conceptual picture of the Earth and the Moon as viewed from Hiten. The spacecraft will soon approach the Moon for the first time and release the lunar orbiter as planned. Approaching the Moon, Hiten changes its attitude and spins upward, triggering the release of the lunar orbiter. "27 minutes after separation, the lunar orbiter's kick motor is successfully ignited. Then the orbiter is named Hagoron, after Hiten's beautiful veil. Then, Hiten resumes its original attitude and swings by the Moon, its closest approach being 16,000 kilometers. This computer graphic shows how the spacecraft has changed its trajectory to encounter the Moon at an exact time and point. During its 5 orbits around the Earth, the Hiten has carried out trajectory correction maneuvers more than 10 times. Now, the first lunar swing-by puts the spacecraft in an orbit about 720,000 kilometers from the Earth at apogee and 110,000 kilometers at perigee. Hiten is a space engineering satellite designed to acquire and verify various advanced technologies indispensable for future scientific space programs and missions. This double lunar swing-by technique will be directly applied to the GeoTail, a satellite scheduled for launch in 1992 for the in-situ measurement of the geomagnetic tail, which extends millions of kilometers on the night side of the Earth. ISAS continues its efforts to solve the various riddles of space by sending spacecraft directly to the Moon and the planets. Hiten continues to amass a variety of results valuable in the area of space technologies that will be required in the near future.